All right, everyone. Welcome. Just a reminder to make sure everyone has to sign in to make sure you get the CPD points and get yourself a lucky ticket. And thanks everyone for coming. Welcome to our TAS General Meeting, first one for the year, March. We're up and running. Little housekeeping. We got the exits to the front, the back, the bathrooms, male, female. Reminder to everyone, give everyone a go, listen to and pay respect to all the presenters. Reminder for affiliates also, keep the discussions to a minimum while others are presenting. You'll get your go, and keep the questions to the end, Q&A at the end of each section as well. So just the agenda. You've got me, Ryan Petkovich. I'm the Tasmanian chapter president and local hydraulic consultant. I'll be just doing the meeting agendas and committee reports, followed by we've swapped it around. CBOS are going to go first for topic 1, followed by Ream, and then Seniflow SFA group for the night. So I would like to acknowledge and thank all our affiliate members. Reminder to designers and contractors, please pass on our details. We don't have and know everyone in the industry, so we want to make sure everyone knows about these nights. They can get involved, do presentations. It's the CPD points are all listed as long as they're technical presentations, of course, and we want to make sure everyone gets involved. So if you don't know, or other state meetings affiliates, please pass those details on, or mine or the associations. Acknowledging corporate members and different designers, and also to our industry authorities. So obviously Tas Water, hopefully we'll get them here again. We've been talking to the Trade Waste Department. So later in the year, hopefully we can get those guys up. Tas Gas always helping out. Tas Fire are going to be the August one. And of course, CBOS tonight, and TPSA are going to come up as well later in the year. Looking forward to presentations. Again, if you have any topics or want to reach out to people, let them know that these nights they can get information out to the industry and can be involved. And welcome to Master Plumbers. Always great, and I always like to call out to Angela for always helping in the background. She does a lot, and with us as well, helping me, and look forward. And also we've got Stacey. Stacey's here tonight. Welcome, and for the industry engagement. So the reminder: the HCAA nights are invites to full members of the Master Plumbers, and by invitation only. And it's a non-for-profit organisation that the members' fees help pay for these nights. So we need affiliates and members to contribute to keep these things happening. So if you like how they're going or want to see more, that's how it happens, by membership and for contributing. Thank you. And you guys, our members, like I said, Tassie Consultants reps, just keep passing on our details. If they don't know and they can do these presentations, just let everyone know when you're talking to them to reach out, because we don't have everyone's details, so we can get that happening. So there's my details are there, and Emily's on the national level, and again, you can get access to other states' meetings as well as we go. And we got some new members here to kick off. You can see some names that you might know: Hydroflow and Tom Condon. I've actually got his certificate, but he's not here tonight. I'm not sure if he's zoomed in just yet, but we've happy to meet Tom. Tom's from up north of the state, representing the hydraulic consultants. So that's great to hear. And keeping going. So some news: the NCC 2025 published in February, but states and territories can consider adoption, and that's a matter for each state. The example there, our state is, it's been noted as a pause implementation. So we're going to stay with the current one. Everyone should be aware of that. And there was a publication that went out as well until further notice. There was also the e-news letters that come around. So since the last meeting in December, some of the articles that are there that you can still reach out and get to read. The job readiness for the plumbing industry, Standards Australia training, TAFE Centre training, medical services for plumbing, mechanical services, sorry, and modernisation of Australia's NCC. We'll see how that goes. And then January, importance of flue inspection, sorry, and that was that, if you all read those articles of what some of the concerns can be. There's a bunch of community consultations out there at the moment, and I'll touch on that as well. Discharge of soil waste into disconnector gullies. There was a notification there for temporary site sheds and toilets and pools. Plumbing ASCON drawings, that's been passed on. It's come up a few times from to the HCAA from the TPSA members, also raising ongoing concerns from councils and consultants not getting suitable as-built drawings for the works being completed. They've mentioned that needs to be able to follow them for future works and for owners to understand what they've just paid for and what they've had. There's a director's specified list if you're unsure, for getting help with your plans by others if you need as well. So that was brought up a few times. Sorry. Yeah, examples put forward were hand sketches with lines with no reference points of buildings or boundaries, sizing of lines, concerns about projects with pump wells with no actual information regarding size or duty of pumps or controls or power locations, etc. were kind of some of the examples that were given for that complaint and for that to be listed up. February, we had some non-compliant Type A appliance installations, and the new system for booking plumbing inspections online anywhere, anytime from the Hobart City Council came through. So that was good. Oh, sorry, ignore that one. So there's some industry collaboration getting announced last month. Currently was in the planning, it's still in the planning phase, and they're looking into depth with a panel into what's needed to be included. We'll keep you posted as the progress, but it's the HCAA and CIBSI and the ICC, Queensland, AHSCA Queensland have signed up to a MOU to develop a critical industry training on sanitary drainage design installations in unstable ground for Australia and New Zealand. So it's a bit of a collaboration in the background that they've been working on online for a future course potentially in that space. So a little bit of the HCAA Teachers Sponsorship Initiative has been kicked off, and the update for that is it was put out to members. Everyone in Tasmania knows currently the diploma for hydraulic consultants is your only option is New South Wales. It used to be in Queensland as well. That's since dropped off the wayside. New South Wales still run it. There is quite a large backlog of master plumbers and designers trying to get into that course. It's currently sitting at around 100 people are on the waiting list. People in Tassie as well are on that list, I know. And from that, it's always been a kick-on problem, and that's why the Queensland one no longer runs. It's because they can't get teachers, and TAFE, I think, is probably in the same boat. It's getting the teachers to actually do these keep those courses going, to mark assessments, to even put the assignments together. So we've been in the background advocating and supporting. A lot of our members and committee members and directors have actually, and Rod Ware, you've all met, he's come down and give a speak before. He's actually one of the teachers that does help TAFE New South Wales. And as a part of the problem is getting teachers in. you have to have your TAE, and everyone's got jobs to do, trying to work in the between. That's been holding people back. So as part of our initiative, we've put forward to sponsor future teachers. So we've currently just accepted 4, I believe, is where we're at, teaching roles. We're going to cover the cost for the TAE qualification in working with TAFE to get that happening, to ensure that the diploma keeps going and that we're trying to get as many people through as we can. So yeah, there's going to be future discussions there, and hopefully, I think Adam from Tasmania is put his hand up for one of those roles. So that's really promising. So yeah, there'll be more on that. So again, I mentioned the public consultations that have gone out, and the HCAA participation members have a chance to respond to CBOS community consultations. Members need to make sure they're reading, just like the master plumbers do it as well. It's there, it's out for everyone. It doesn't have to just come from the association. We've sat down in private meetings. The invites go out to members to come and have those discussions. You need to be a part of it if you want to see change that benefits the industry as a whole, and that's what those chances are. So we've just recently, currently there's out for discussion. There was the termination, prescribed maintenance and essential building services. That one's had some comments put forward, and there's still more to come. You can see the plumbing approval process reform, occupational licensing bill. I think that one just closed. I'd have to check. And again, they go out in those newsletters and to stakeholders, and you need to be a part of it, just like the NCC and the standards. If you want to see positive change that you see need to be reviewed. And what did we just had recently? World Plumbing Day, March 11th. What was it? The plumbing industry addresses complex challenges such as water scarcity, poor water quality by improving the performance and affordability of connected systems. Solutions such as water reuse, smart plumbing, systems integrated and with existing networks to manage water safely and efficiency, proper pipes, backflow prevention, and effective waste systems protect the integrity of connected water supplies. So there you go. That's a little bit of World Days. We got a double up. We got the World Water Day also happened March 22nd. This year was water and gender, and where water flows, equality grows. When women and girls have equal voice in the water decisions, services become more inclusive, sustainable, effective, and we must invest in women's leadership to make water a force for healthier, more prosperous, gender equal futures that will benefit us at all. So those ones happened just recently. And also Women in Construction Week happened 2 weeks ago, I believe. We welcomed it as an opportunity to celebrate our female members and shine the spotlight on a handful of them throughout the week. And for those of you who do use the association's LinkedIn and social medias pages and newsletters, you would have seen a few female members pop up, and that's positive change that you'll see. Our industry is changing, and everyone's coming along. And thank you to everyone here. And with Spotlight here, I've got quite a few, and they've been they're going through on the internet side, but you'll see we've got Emily Park. She won an award last year. She's a new up and coming hydraulic consultant, and yeah, she's there. And we've got Jennifer, Mia, and you'll see we've got a lot of women that have come through, and also our reps as well, and celebrating our members throughout. Okay. And then in South Australia, their update is this year's was also there. 5-year anniversary. It was a great night. I got to go along after our meeting here, and is a that just pop up? I don't know. Oh, well, that's always more fun in person, I guess. But it was their 25-year party for being the industry body down there. So, and it's great, and you can see Tasmania's been running for, this will be our 5th year as well. So there is planning going on to see what we can jazz up and have some fun for our 5th year anniversary down here. And sponsors are still welcome to open and be announced as we progress. So venue, entertainment, dinner options are in the works, see what we can do. Yeah, see if we split it off or have a separate thing, or if it's just the November night that we just blow out a bit. Recent other news posted on the website pages to members. 1851 2012 is now mandatory in New South Wales. It's already been implemented. Like, everyone's doing that down here as well. So nothing really new for Tassie, but yeah, other states are now implementing that if you're working in other areas. NCC 25, like we said, the preview's there, but it's not really happening. New South Wales Storts hose connections technical sheet was updated. Unfortunately, I can't confirm if TFS have also backed or changed their one, but they're going to be here in August doing a presentation, which is great. So they might have some more to say on that night as well. So, yeah. Okay. Just a reminder, what would you like to know? What do you want to hear? We want to hear from you guys. You got the hot topics, like always. I'm going to bang it into you. They're on the tables. I've also got a QR code that Emily made up last time, so you can just scan it if you don't want to sit there and write stuff in front of everyone. It's not a secret, but by all means, fill them out. Yeah, anything. It can be companies that intrigue you that you want to learn more about, topics, problems, frustrations. It's all there. You know the drill. I'm going to keep saying it to you. Some of the meetings coming up these ones have just gone. Obviously the Adelaide one was last week, which is great. Our one's tonight. Newcastle's the next one. Again, members can always zoom into those meetings in other states if you want to find out what's going on. And there'll be more posted later on through the year. EGen have thrown out a competition to win a trip to America. I didn't. Janet, you have to reach out to Jennifer and have her come and do some in-house presentations if you want to be a part of that. Sorry, contractors, it's not open to you guys. There's probably a separate one out there that they've got going on. But that's just something that's going on. I can't say more about that. And then I might just quickly call up Peter McCullen from the Backflow Association.
Yeah, hi everybody. It's great to see everyone again. Just a save the date for our conference, our national conference that we're bringing to Tasmania in November this year. It might line up with some of the stuff you're doing, but it's 4, 5 and 6 of November. There'll be a Contractors' Day on backflow prevention, maintenance and testing and troubleshooting and that sort of stuff on the first day. The second day will be regulatory and designer technical papers, and the third day will be Legionella, because the Legionella Management Advisory Group is part of the Backflow Association. And we'll be running all those courses. We'll be applying for CPD points to allow for those courses. And it's going to be a conference that we keep the prices down, and it's done particularly for the Tasmanians, because we expect we'll get about 80% Tasmanian content or attendees. But it is a national and international conference, so you will see people from there as well. So any information, reach out to me at the Backflow Association, or you'll see advertising as we go forward. Thank you.
So yeah, that's going to be an epic 3 days here as well. So that's really great for the industry, great for everyone. So that will be really fun to get involved with. Okay. These ones actually were just a reminder from November. Just Taswater haven't published anything else for us to put out. Hopefully, like I said, we've been reaching out for trade waste. The two updated documents were from the last one. The guidelines for development assessments, you'll see, had an update. Backflow boundary containment, that was also amended. So those ones are there. Hot topics, again, I've just wanted to put that out there. I could see everyone jumping at it, so that's really good. Hopefully by the night you'll put something down for me. It'll be great. All right, little fun time of the night. Just reminders. Look, it's a beautiful install. Ton dishes was a question. Look at this. So you can see it's a very planned install. There's tags, supports, labels, ton dishes. Always consider locations of where these things are installed. Is it discharging to a point where the ton dishes are known? Does the rooms have floor waste? Has the annual testing been carried out? So all those things to remember. Is it an internal or external space? This one, I probably could have put another external photo there, but you can spot the compliance issues. Reminders always of locations and changes. Obviously, also when doing replacements, you need to have your considerations as well. So you can see this area might have once been an external zone that's been built in. It's also now a chemical store area. What was there before? The place has changed. Walls, doors. What's adequate airflows? Would a side diverter even make this compliant, or would it need to be flued out completely? So always things to consider. And then, like I've said before, it's all free. It comes from both sides. So the association and CBOS, TPSA, we all get different things, comments made, and contractors do reach out to us as well. and you can see that they're calling out some designs that are out there, things to be mindful of. Consultants, they've asked, contractors are getting smashed out there for compliance, as we know, in regard to level of documentation from hydraulic consultants, mechanical engineers, civil engineers, building designers doing hydraulic works as well. But yeah, there's parts there that could raise questions about how do you drain ton dishes that are listed above benches, but the units are below. So, and plenty of different things going on. So it happens on both sides, guys. So just, yeah, always people can put things forward and we can get that out to the industry. Okay, I said it was coming up. I've put it in there one last time. Please fill them out. I do have some stuff there. So what happened in the, sorry, it says August, but that was November. So again, defects that have been getting seen from people. ORGs seem to be listed quite a lot. Common upsets on designs. We had ground movements and overcoming design issues. So there might be lack of detail or not enough, or was it suitable? Another example of design complaints were pipework materials, PE sizing, ID, OD. Presentations that were kind of put forward were estimating should be mandatory in Cert 4. I would have thought that was a mandatory subject in there somewhere, but there was a comment made. Presentations on specifications or guidance, that can be taken on as well. And the Master Plumbers have asked, what training do consultants and plumbers think is most needed in Tasmania? So that's a question to all of you guys to put down. What do you think plumbers need? What do you guys think the most topic or subject needs or reminding? So that was actually put there for them to gather some information too. So again, I can see you all reaching for the pens, so that's good. Reps can put something down too. You guys go to plenty of sites and see what's out there, so feel free to write some stuff down. Okay, and just a reminder, Emily's here to help. Feedback, topics, like I said, you can reach out, put anything to the association. It will get there eventually if it needs to go to the directors or anywhere else. Yeah. Thank you very much. That's my little section done, and we'll quickly bring Matt Lloyd up for trivia, and then we'll roll on.
Thanks, Ryan. Yeah, we did this once before. It seemed to work. The idea is to get people talking on your tables. If there is a table that's jam-packed and there's a table near that's probably needs one or two people, if you could kind of slide over. Happy World Plumbing Day, everyone. If you've got a plumber on your table, it will help tonight. Don't have to, but if you want to nab one, that'd be great. The usual rules, no phone use during the game. If you do go to the toilet, you have to take someone from another table with you. Choose someone with good handwriting that might be able to write this down. Spelling's not too critical, but and another thing is it helps if you don't yell your answer out if you know it, because the other table can probably hear it. But okay, so there's 3 rounds, 3 questions per round. Round 1, question 1 is and remember, everyone, there will need to be a scribe on the table. So if someone could, what's the 3rd largest copper structure in New York? If you were in Sydney last week, some of these questions are going to be familiar. So a bit of an honesty system. I can't really see any faces that were there. But anyway, so the round 1, question 1, what's the 3rd largest copper structure in New York? 3rd largest? Question 2. Question 2. In Australia, 90% of this state or territory is considered arid or semi-arid. It is the driest in Australia. Which state or territory is it? So I'll just repeat that. in Australia, 90% of this state or territory is considered arid or semi-arid. It is the driest in Australia. Which state or territory is it? And question number 3 relates to that basket that's in front of you. So that basket there, and happy World Plumbing Day again to all the plumbers. I am a plumber myself, and I did have to get some clarity because I will take the questions that are most relevant to Tasmania as a description. But I need 3 points of description for each of those fittings on the table. So there's each of the fittings is labelled 1 to 5, 1, 2, 3, 4, 5. And if you look at the fitting, it's got a number on it, and I need 3 relevant descriptions for that particular fitting. Can I say a big thanks to Reese and Gavin Wild? Where are you, Gavin? There's Gavin up the back. I did travel with some of this stuff, but I didn't want to take too much on the plane because hand luggage and carrying potentially, as you can imagine, what that looks like on a security camera, all that stuff. But speaking of security cameras, Gavin and I do know how many PVC fittings are in the room. So with the oil crisis at the moment, we don't want to see those PVC fittings leaving the room. Okay, so that's round 1, 3 questions. Good luck.
Okay, we're gonna roll through, and then some dinner will come out. So that will be great. Maybe I'll just say. Should I give everyone a break? We good? Okay. All right. Okay. I just wanted to tell Thomas Cotton that I've got his certificate here, so he has to come down to Hobart next time and pick it up. So good to see you, mate. Okay, and now we're going to roll right through to the first topic. We're going to have CBOS here, everyone. All things plumbing, insights from Owen Smith first, and Adam Johnson is going to come up as well. Please welcome Owen Smith.
Yeah, I'll just work with that. That's fine. Thanks, Ryan, and thank you to not only Ryan but the association as well for giving us a brief moment to discuss a couple of topical items that have come to our attention recently, and in terms of some government initiatives that are happening as well. So basically, there's 3 minor topics I'll run through. Adam will then finish off this with a bit of a discussion relating to probably some government decisions around plumbing approvals process, what may transpire in relation to that. So we'll just push off initially with this first subject. Now, obviously, you'd have to be living under a mushroom to have missed the whole thing with lead-free in the lead up to 1st of May this year. Now, if you'd spoken to me back in August of last year, I would have said, yeah, we're on track. 1st of May, lead-free will be, all lead-free for copper alloy fittings will be locked in and be prohibited from that date forth to install anything but a watermark certified lead-free fitting or component. However, around about August or so, there was representation from a number of manufacturers, retailers, wholesalers, etc., large building groups, who were saying that there was still significant stock of old watermark or previous watermarked items out in warehouses, etc., to such an extent they gave it a figure of some millions of dollars. Quite frankly, the regulators around the state and territory regulators were somewhat flabbergasted that after the lead up to this, that circumstance was in place. The regulators had no means by which to verify or otherwise that claim. Nevertheless, the situation proceeded, and the ABCB, the Australian Building Codes Board, had a meeting number 5 of the year, met in December, and based on those representations decided that the rollout of lead-free would be delayed until 1st of May 28. Okay, so that's why we've been a bit quiet lately in terms of our communication to you, because this was all happening in the background. We did have a newsletter around July saying to everyone, you know, start prepping for this, etc. Part of my job was to try and ascertain to some extent how are we off in Tasmania, and I have some level of satisfaction that our suppliers, our main plumbing hardwares, were well and truly down the track of converting to lead-free watermark ahead of schedule, probably better than most other states. I think in terms of what plumbers, how plumbers will experience this come 1st of May, is you won't really notice the difference. Most of the stuff on the shelf is marked lead-free now. The ABCB and Watermark will issue a notice of direction, an amendment to the notice of direction 2022/4, where the date for the rollout of lead-free will be now extended to 2028. That notice of direction has yet to be issued. It's getting a little bit long-winded, I've got to say. We're operating on the outcome of the meeting in December, as are all other states and territories. As of 1st of May this year, the manufacturer of a component used in for drinking water purposes will be prohibited if it has the a lead content higher than the 0.025%. Okay, so current watermarked copper alloy can have lead content up to around about the 4% mark, mainly for machining purposes. But as many of you would be well aware, that under certain conditions where aggressive water supplies, poor commissioning processes and flushing, the natural patina that would form in the brass within piping systems can be degraded or not form at all, and we can actually get leaching of lead into systems. So that's still going to be an issue. If you hold previously watermarked stock that is certified and holds a current certification, you can still use that stock post 1st of May. Okay. Our preference, best practice, is go for lead-free every time. All right. However, retailers, wholesalers will be permitted to move that stock off shelves. I have been led to believe that the main impact will be around our large diameter valve systems and a significant amount of tapware. All right. Most of our installation fittings seem to be well and truly down the track of conversion. So I would imagine you would have noticed this for a number of months now, that you're picking up a particular valve or set of fittings. It's already been marked lead-free for some time. Okay, so look for that certification as a preference. If you have any questions around the certification of a particular product that may not be marked lead-free, get on the website and try your best to work with the Watermark website and check that certification. If you're still having dramas, particularly designers, if you're trying to specify a particular product, we're here to help if we can. We all know the Watermark database is, to put it kindly, difficult to search with. It is one of those things. So if we can assist in any way, let us know. So just to draw a line under that, 1st of May, It will be prohibited for the manufacturer of any product in contact with drinking water to have a lead content higher than the amount stipulated in the NCC 2022. The extension for installation runs through to 1st of May 2028. Once the notice of direction has been posted by Watermark, we'll obviously get it out on the CBOS newsletter and any other means of communication we have. We are running out of time, of course, because given the date that we're at the moment. So it is to be brought up again at tomorrow's board meeting as a bit of a concern. But that's our status as it stands at the moment. Okay. If there's any questions, we're more than happy to deal with that. If you contact cbos.info email address, and we can help you if we can. Okay. Next item. The New South Wales coroner has just released the findings into the death of a woman, recent death of a woman by scalding. You know, any of you who are plumbing back in the 90s, I mean, I can remember when tempering valves were first entered into the standard. I would find it hard to believe that here we are 30 plus years later and there's people still dying from this. And not only that, if you look at the New South Wales coroner's website, there's 4 other deaths in NDIS facilities. This one in particular, this will be coming out in the CBOS newsletter in the next day or so. It's to our mind, and I think any fair-minded person, is of such importance. We've applied a CPD point on its download. There'll be a link inside the in the CBOS newsletter. Click on the link and your name and license number or whatever will go into a register, and that CBOS point will be counted for your next license renewal. We know get sometimes every point counts, but more importantly, this is a person. The woman's name was Judith Ingram. She ran a bath. She was elderly. She used to run about 3 baths a day. At some point, the coroner believes she topped that bath up. She laid back and suffered full thickness burns to 16% of her body. So basically what happened was ambulance was called, etc., etc. And as is often the case with burns, it's not the burn itself that kills you, it's the sepsis that gets into your body after the burn. And being elderly as well, she died about 3 to 4 weeks later. All right. An investigation was launched. The coroner has looked into it, found that the plumber did not install a tempering valve on a cylinder changeover. Okay. Not only that, that water cylinder thermostat was bumped up to 70 degrees. Why or how, the coroner has yet to find out. The coroner has referred the nominated manager and the contractor to WorkSafe New South Wales, which means for prosecution. Okay, so possible criminal charges. Okay. So we believe this is something, it's a bit of a wake-up call for our industry here in Tasmania, particularly to our nominated managers. Think about what's going on. What are your staff, what are your plumbers doing? Are they ensuring that the tempering valves are going in? Tasmania was the first state in Australia to move towards mandatory mandatory installation of a tempering valve on changeovers. We are providing a link within the CBOS newsletter to our fact sheet, which distills the information within the PCA, B2D5, B2D6, etc., into a set of scenarios that plumber can read through the actual table and determine whether they need to actually install a tempering valve or not. Okay. The New South Wales situation relates to what they call nominated supervisors. In this state, that's a nominated manager, same responsibility. So the contractor is held responsible and a nominated manager is vicariously liable and therefore is also responsible for the actions of a person in that company. All right. And this is of a particular concern to us because we get a lot of reports about certain businesses that employ remote nominated managers, someone sitting in an armchair signing 71Bs, not even involved with the business, things like that. People that have purchased qualifications on an RPL basis over the internet, haven't actually done the training, wouldn't even know what B2D5 or B2D6 says. All right, in this state, that is vital. You must know what the TAS appendix says and your PCA says. If you don't know, download the damn thing tomorrow and find out. We can't have this happen in Tasmania. All right, so heads up, have a look at it, do yourself a favour, pass it out to your staff, get them to look at this document here and ensure your company is doing the right thing in this regard. It's been in place now since 2019. Righto, next one. Oh yeah, this. Oh gosh. Okay, so I think everyone's pretty well on top of this now that the Tasmania will not be adopting NCC 2025, and as such, staying on NCC 2022, the primary and secondary reference documents within NCC 22 remain our DTS solutions, right, for the foreseeable future. When we know, we'll let you know. But at this stage, we have no horizon on when this may or may not change. So your DTS sits with NCC 22. The rest of the states around the country will be starting to transition. I think Victoria goes in October over to NCC 2025. For designers who are doing collaborative work with other designers interstate, you need to be very mindful of what you put in place here. If you're going to be using the AS 3500 in 2025, that's fine, but it has to be a performance solution. Okay, so just be mindful of that. Plumbers need to start checking your designs over the next 12 to 18 months and ensure that the specifications list the particular Australian standard that is pertinent, because don't assume the standard you're meant to have in your truck is the one you should be reading for this particular job. Okay. We've got no further update on how this may happen in the next few months. At this stage, until further notice, we stay on NCC 2022 and AS 3500 2021. Okay, I think it's pretty well widely known. If you have any doubts, if you have any questions whatsoever, please don't hesitate to contact either Adam or myself and we'll try and walk you through it. All right. Yes. Yep. In actual fact, historically, we were ahead of the pack. Until NCC 22, we had automatic adoption of standards. So when a standard came in, we adopted it straight away. That was under NCC. It's a decision made by Tasmanian government. That's all I can say. Yeah. Any other questions? Yes. The association, any association, MPA, or members or individual plumbers can always make suggestions, recommendations through either ministerial channels or through CBOS, the Director of Building Control, Executive Director, etc. 100%. You're the industry. You're there to ask questions, and if you have a particular perspective on things, you should be voicing those concerns or ideas. 100%. You should never hold back on that sort of thing. Yes. 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 Lack of what, sorry? Yes. Mm. Mm. Really?
Government is trying to keep people in their own houses, etc., etc. Aged care comes under federal jurisdiction, and I don't know, I'm just, like what's happened to that lady, it should never happen in this country, ever.
No.
But
No, I agree entirely. No, and the rules are there to prevent it. Yes. Mm. Yep. Yep.
half of that's all about keeping old people in their houses.
And
Yet we're
yep.
still paying.
If you look at even the current NCC, there is no reason, if the provisions within that document were observed, that anyone should be getting scalded like this. It's where they're not observed, and where the breakdown is, whether it's through design, through building surveyor assessment of a particular building, whether it's the plumber who's missed out on it, it's the lack of observation of the core requirements, the core safety requirements and obligation of a plumber to protect the community. That's where the failure is. You're 100% right. But it's not a lack of regulatory oversight, regulatory guidance. It may well be oversight, but certainly the guidance is already there and the provisions are already there to protect the community. It's the lack of implementation and correct observation of those. Yep, I agree entirely. There are concerns relating specifically to a lot of the NDIS stuff. I do concede. Yep, sorry. Certainly, and inspectors do and do pick up and pass on to us where they've discovered issues like this. But inspections will normally only occur for notifiable work or permit work. Where a lot of the hazard is, particularly in this instance here, is that a water cylinder changeover is classed as low risk work, and so there's no oversight from the inspectorate in any sense. The permit authorities are absent on that, and to some extent won't even know that it happens. That's the obligation of the certifier. That's the legal obligation of that nominated manager and contractor to ensure it's done in accordance with the NCC. But it's a good question. Yes, Ron. Yep.
Where can we stand, or where can we say, instead of putting your hand up and you walk away from the job, which you might do, and let someone else take the risk of the changeover, is there a CBOS contact or a council contact or a notification that can assist maybe these guys for carrying it a bit more when they say, well, it's a standard you need to comply with? Thank you very much. But you know what I'm saying?
Well, 100%, and that's a very good point, Ryan. And there's a bit of a demarcation between two things here. You have, in the first instance, historical installations that may have been compliant at the time when they were done. And then the Act doesn't require retrospective upgrade of those facilities. However, then there's the other side of it where if you identify defective work that was never compliant, a responsible person has an obligation to report that to the permit authority. And if you get no joy there, you can report it to us we can maybe pass it on. All right. So that may be contentious, particularly in your relationship with your customer. But if someone's life is at risk, that overrides those other concerns. We referred one to a permit authority recently where it became apparent to us that there was a risk to life and limb from a hot water install with no tempering valve. Everything else was wrong about it as well. But we contacted the permit authority and they were immediately on top of it. They have the power and the ability to then go out and require that to be repaired, okay, and rectified. So this is an example. It does work if you use the processes. If the processes break down, if you don't have the contact, let us know and we can try and assist in that process. Someone had their hand up here, Ross.
This,
Yeah.
they call it residential. It's a class 2. It's not a class 1.
Yeah.
So we're controlled by a lot of the building surveyors.
We are very aware of that situation at the moment. Yeah. It's work in progress happening there slowly. Yeah. Any other questions? All right. Thank you. Any question? If anything comes to mind later on, give us a yell. Please keep an eye out for the CBOS newsletter in the next couple of days, and have a look at it. Download that link. We'll register that CPD point against that information. It'll be on the drop down, and that'll count to your next license renewal. And please pass it on to everyone you know as a heads up. We don't want this happening here in Tas. I'll just finally on that the New South Wales coroner has recommended to the New South Wales government that changeovers of water heaters be notifiable. All right, so that upon completion, that notification to council. So that may be something that may flow through to other states and territories down the track once the big state makes a move like that. All righty, I'll hand over to Adam, who wants to talk about a little bit of detail in the current reform of plumbing approvals processes. That's your magic button there, mate.
Thanks, everyone. So last year, the state government made an announcement through the election commitments that they would be looking to streamline plumbing approval processes for standalone Class 1A buildings. There was some talk about self-certification and removing completely pre-notification and inspection of those works for new buildings, which came through to us to actually enact that commitment. And so today I just wanted to bring your attention to a consultation out at the moment, which is the new process, which is going to be a fast track. We've managed to revive the concept of keeping pre-notification at this stage. We've managed to keep inspection of that plumbing work for obviously the liability and risks associated with drainage under slabs, cost of rectification. So this document's going to be out for consultation until I think 22nd of April. And we really need the feedback from industry. That's going to be designers, it's going to be plumbers, whether you support it or not. We really need to hear from you if you've identified risks that you think are associated with the new process. That's really important feedback that we need to hear. Whether there's going to be other things carved out, whether there's inclusions that you think can go into it. Have a look at the document. I don't want to go through it tonight, but essentially it's going to be streamlining that upfront administration. So it's more a notification that those works are taking place. There'll be a series of documents that will be required for the plumber to submit to council. They'll check off that information, that there's a planning permit in place. Soil classification is going to be picked up, and then that information is going to be verified through council to say, yep, head off and go do the work. We'll see you at inspection for that drainage inspection. There's going to be a fair bit of transition involved. There's going to be a lot of education required to get that up to speed. But yeah, obviously we can't think of everything not on the field. And so we really need to hear it from plumbers, whether you think that something like that can succeed, whether there are too many risks involved with going to essentially a lower level of oversight from council at that initial stage. And yeah, it's essentially, it is a call for feedback, but you know, it is a really important one that we need to pick up because we essentially need it supported, you know, in some shape or form, because the alternative of what was suggested was that plumbing be moved to low risk for Class 1A buildings. And we'll see you, you know, once your drains are blocked up 3 months after you've moved into the house, and we're going to come and cut the slab up. So have a look at the document online. It'll be in the newsletter. There's a link to the website. Have a read of it. More than happy to talk about it. Our details are there. A lot of you have got our personal contact details at CBOS. So if you want to talk, we can come out and visit councils. We just want to get the correct information out there so everybody understands very early on what this is going to look like, so that we can try and identify some of those risks before anything proceeds too far. So that's all from me. But yeah, have a look, let me know, and get in touch. Thank you.
All right. Thanks, Owen. Thanks, Adam. That's really great. And I think there's a lot there for everyone to digest. And basically the take home is, I think, get involved and read into what's getting put out there. I think we'll just have a break now, and then we'll do trivia after. There's everyone have a meal, have some drinks, have some chats, and then we'll come back.
Potentially moves to so that is the guidance. There's no possibility in the moment so we're not going to back 3 training for you for whole layout, and there's nothing else to continue with the second category. So it's still it's low why not? And I think personally, but in plastic bodies, so, That's the issue of class of the building. That's why it's simply almost the base of every partner. Maybe only the recognition of all those facility and that's the recipe. As long as I can we don't play in
Okay, we might get ready, grab a drink, go to the loo, and we'll kick off pretty quick. Okay. All right, everyone, we'll take a seat.
Okay. coming up too?
No.
Yep.
But he will,
Perfect.
which I will.
All right, everyone. We're up to topic 2. We got REAM, commercial heat pumps and electrification, insights from Peter Coots, and Scott Johnson's here too tonight, so we can razz him up as well if we need to.
Definitely. Thanks, Ryan.
All right.
Just press the button, do I know how to use this stuff?
Yes. And you can push the buttons there.
Can push as well.
Yep.
Even easier. Hello all, my name is Peter Coots. I'm one of the technical sales managers for VicTaz for REAM Australia, hot water. Scotty Johnson standing here all on his own, which is normal. He is our commercial sales manager, so he looks after both Victoria and Tasmania. I'd like to start by thanking Ryan for the opportunity to present our products to you guys down here, and thank you to the HCAA members that have come along tonight to listen. You know, these sort of things don't obviously happen just with the click of a finger, so people put some effort in. It's great to see such a terrific turn up, better than I've seen in some other states, to listen to what people have got to say. Tonight, I want to have a bit of a talk, and I was threatened not to make it a REAM sales night. Unfortunately, REAM do pay my wages, so I will probably mention their name from time to time, but I want to try and just make it a general insight, I guess, into commercial heat pump. I guess the reason we're doing that is we are now seeing in Victoria, and other manufacturers here who also do heat pumps, I'm sure, are noticing the same thing, that the amount of heat pump that is now getting sold in Victoria far outweighs gas product. So particularly on the commercial side. So we're seeing a lot of people going over to, when I say going over, probably being forced to go over to heat pump and electrification. So obviously, if you're going to go to electrification, there's only a couple of options you've got available. One of them is heat pump. The other is standalone storage electric hot water systems, which have always been obviously very big down here with the tariffs and things like that. And the other one is instantaneous electric hot water, which we cover all categories of that. So we've sort of got a good cover on those things. What we're presenting tonight is our newer product, which is the REAM commercial heat pumps, the R1234YF. And we honestly did not make up that number. That is the name of the gas or the refrigerant that's used in these products.
REAM has been leading the development of commercial-grade heat pumps for over 15 years and continues this tradition with its latest product advancement, REAM YF Series commercial heat pumps. The REAM YF Series commercial heat pump range employs R1234YF refrigerant, which has an ultra-low global warming potential of less than 1, making it one of the lowest GWP products commercially available.
Why YF1234A? It's something that's been, I guess, requested and pushed on us by the environment. The ESD people and people like that are looking for more environmentally friendly options or solutions to heat pumps. Traditionally, heat pumps, most heat pumps that were on the market were using a gas called R134A, which is a type of gas we all used to be fairly well used to. It has a GWP, as you can see there, of somewhere up around the 13 or 1400, compared to CO2, which is the benchmark, which has a GWP of 1. The YF product has a GWP of 0.5, so it's better than CO2.
The global warming potential of a refrigerant gas refers to the total contribution to global warming, resulting from the emission of 1 unit of that gas relative to 1 unit of the reference gas, carbon dioxide, which is assigned a value of 1. R1234YF has a global warming potential of 0.5, which means that 1 kilogram of R1234YF has half the impact potential on climate change as 1 kilogram of carbon dioxide.
So that's basically the reason why we're looking at, we're not looking at, we are now using R1234YF. We've also made some other changes to the product to accommodate that gas, which I'll run through in a second. But we have that available now in both a 15 and a 30 kilowatt unit. So that covers off most of the sizes that we have needed to have available. We have done some installations where there's been 16 or 20 of the 30 kilowatt units. So they're quite large installations, and they may have 10,000 plus litres of storage hot water. So they're quite very large installations, and these are something that I guess the architects and the consultants, it's new to them because of the amount of space and the amount of weight and those type of things that they have to allow for in these newer type products.
The Rheem YF series heat pump produces hot water up to 65 degrees in the storage tank and operates between 0 and 45 degrees ambient temperatures.
When we say up to 65 in the storage tank, we're getting 70 out of the heat pump. So without any electric boost, without any help at all, the 1234 is giving us 70 degrees out of the heat pump. So if we can get 70 degrees out of the heat pump, we can easily maintain a constant 65 degrees in the storage tanks. So we're then setting the water out at 65. You'd normally allow for about a 5 degree drop, Ryan, in a circulation system. So you've got water coming back around 60 degrees, which covers you off of all those Legionella problems and that sort of thing. And you're still not using any electric boost. So it's working very well for us. We've also made some other changes to the way that the
Rheem YF
134 unit
for
works.
higher coefficient of performance by tuning the performance in our on-site psychometric chamber. An electronic expansion valve replaces the older style mechanical TX valve, and a reversing valve replaces hot gas bypass, providing faster de-icing in low ambient temperatures.
So we've made some changes by getting rid of the mechanical valve inside the unit that did the de-icing, that sort of stuff. We're now using a electronic valve. That's improved the performance of the unit, particularly in lower ambient temperatures, which should obviously be an interest down here in Tassie. And it's also increased the COP, or coefficient of performance, of the actual product. So we're getting an increase in COP of up to 4.23. Oh, that's working. 4.23 on the 30 kilowatt, and improved by 10% on the 15 kilowatt. So it's made some real advances to the actual unit as well as just changing the gas.
Further product enhancements allow the YF series heat pump to operate reliably in ambient conditions to a low of 0 degrees C, reducing the reliance on auxiliary electric heating element boosting, which improves overall annual system efficiency.
So operation down to a low of 0 degrees, as it said, allows us to not have that reliance on auxiliary boosting. If we were doing a medical or critical installation, hospitals, some aged care facilities, things like that, we would still have electric boosting. We would have it here, we would have it in Victoria, we'd have it in New South Wales. So that's just a backup where I guess it's critical that the customer is left with hot water. So in those situations, we would still have a backup. Generally speaking, as a rule of thumb, on the majority of installations now, we don't use electric boost at all, unless it's requested. Some consultants will request electric boosting just for some redundancy, but unless it's requested by the consultant, we are not using any electric boost at all on our YF products. Remembering that with these improvements, that even at an ambient of 0 degrees, we're still seeing a COP of 2.6. So that means that it's still 2.6 times better than a standalone electric unit at 0 degrees. So when people say, oh, it's not going to work in Tassie, it's too cold and all that sort of thing, that's rubbish. Of course it'll work. And it will still save money. The new controllers that we've introduced into these products, which on the 15 kilowatt, there's a single control. On the 30 kilowatt, there's a double control. You'll see why in a second. It now monitors up to 11 different parameters. Incoming water, outgoing water, water in the tank, water in your return lines. It's monitoring gas pressures of refrigeration on your inlet side, on your outlet side, everything. So even without BMS, you can still get all that information out of the controller by pressing a button. BMS is great. It'll give it to you back in a remote area, but you can still get all that information out of the unit by the press of a button on the front of the unit, which for diagnostics, refrigeration mechanics, things like that are finding it incredibly useful. Saves them carrying around those Mickey Mouse ears they all used to walk around with. It supports BMS. The unit comes standard, able to take BMS. So what we do is we add a BMS card to the unit. We don't know at the time, and usually even at the time of delivery, we often don't know what type of BMS is going to be used. So we make a card in both Modbus and BACnet. So depending on which one's going to be used, you purchase that card. It'll be put into the unit, usually when we'll do it during commissioning, or the plumber can slip it in. It's only a matter of pushing the card in. The BMS technician will then take over. He will adjust all the parameters within inside the unit to suit what he's looking to get out of it in BMS. The unit, if you're only looking for a run fail, that's already built into the unit. So you'll get a run fail output out of it without adding the BMS card to the unit. If you've got the 15 kilowatt, you can daisy chain the BMS up to 6 units. So you can have 6 units as a, used to be able to say master slave, you're not allowed anymore. I got told off for that. It's now student and teacher. But you can have them set up as a student and teacher. I don't know which one's been boss yet, but so you can have up to 6 units connected together. So you then only have to run one BMS card back to your BMS station. That saves a lot on installation. For reasons I'll show you in a second, we can't do that on the 30 kilowatt. So you need a separate BMS card for each 30 kilowatt heat pump. The 30 kilowatt models are a dual refrigeration circuit. So basically they're 2 15 kilowatts in the one box, and they're 2 separate circuits. So you've got some built-in redundancy in a 30 kilowatt unit. You've got 2 15 kilowatt units in there that can run independently, and they will stage and rotate. The same as if you have the 15 kilowatts hooked up or daisy chained together, they will stage and rotate as well. Okay. The reason we can't have the BMS connected on these units is because it's 2 separate refrigeration units and we can't get them to talk to each other properly. But all these things are being worked on. So that, I guess, is an explanation of the product that we're using and the products that are out there in the that's being used in the market today. All manufacturers are using different gases. They'll tell you what's good and bad about theirs. That's what we believe is positive about our product, the YF heat pumps. So if anyone has any requests for information or that sort of stuff on those, any of that, I can supply that all to you. We now want to look a little bit about sizing. And sizing, I guess, is it's arguable. Everybody sizes differently. All manufacturers probably size slightly differently. There are some things when it comes to sizing that don't change, like formulas. David, I'm sure, could tell you we're still using the same formulas today that we used 30 years ago when it gets to how much water an element can produce and how much water a megajoule of gas will produce and that type of thing. So those sort of things haven't really changed. So tonight, as a bit of an exercise, we want to look at the different ways of sizing the same project or job using one tank pack, gas tank pack, this type of thing, where you would have a bank of instantaneous gas units and a storage cylinder. We call ours a tank pack, up against a heat pump system. So what we're going to be looking at is in Tasmania and areas like Melbourne with a similar moderate climate, and it is really a moderate climate, it's not almost an alpine climate, we allow for an incoming water temperature of 15 degrees. If you jumped on, and I tried it in Tasmania and I couldn't get it, but if you get on any of the Victorian Water Company websites, they actually advertise what their average yearly water temperature is, and it's about 14.7, Scotty?
That's the lowest.
That's the lowest temperature it gets down to is 14.7. So we're working today on a 15-degree ambient. I'm sure that somebody could go up into the hills down here in Tassie and find the water colder. And we have formulas for that too. But that's generally what we're speaking about when we're talking water. For colder climates, we have the same calculations, but we use a 10-degree ambient. Okay. Considerations to take into account when you're sizing. The first thing, and probably the most important thing, is the peak demand period. You need to know over what period your peak demand of hot water is going to be needed, and that varies. You need to know what your temperature rise is going to be, so you need to know what your ambient temperature of your water coming in is and what temperature your customer is looking to get water at, or what temperature you are designing that system to run at. You need to know whether you're going to go recovery against storage, and that may come down to the type of fuel you've got available. Not everywhere's got gas. Not everywhere's got enough electricity. So there's a combination of the two sometimes. Redundancy, what type of installation is again, and whether you need to build some extra redundancy in there, more so than what the unit will just do. And the building heat losses. And that's something obviously the consultants in the room would be very aware of. They are responsible for designing the system to a given building heat loss. Okay? But they're the things that you need to take into account. If we're doing apartments, commercial offices, EOTs or end of trip facilities, hotels, we allow for a 1 hour peak. We know, and we've been doing this for a long time now. Reem's just clicked over 80 years old. We've been making heat pumps for 16 years here in Australia. All of our commercial heat pumps are made up at Riversby. If anyone knows where Riversby is in New South Wales, that's where all of our heat pumps are actually made, up there. So we've been doing this for some time, and we've done a lot of data reading on projects and things like that. We know that these figures are pretty accurate. So for apartments, commercial offices, those sort of things, we go over a 1 hour peak. For hospitals and aged care, we normally allow a 2 hour peak. Often for an aged care facility, it doesn't come down to how many showers there are or how many people there are, patients there are. It comes down to how many nurses there are and how many they can wash in an hour. So those things are all variable that you need to look into. Obviously, we always size for the largest peak. So we have a theory at Ream that nobody's ever complained about having too much hot water. We've never had one phone call, I don't think, so far. So we're going to stick with that. The peak demand period is the average hot water used over a period. So our example's 400 litres. Average flow rate of 400 litres divided by 60, of course, for minutes, 67 litres a minute or 1.1 litres per second. The actual flow is obviously going to vary up and down from that, but that's what we're basically designing it all on. If we had an application such as apartment blocks where we have a peak period, a high kilowatt output heat source such as gas or RAPAC, if people remember RAPAC, allows us to minimise the storage to about 10%. So if we were doing a tank pack or a RAPAC installation, we would normally allow for a storage size of about 10% of the peak hour demand. If we're doing a low kilowatt output system or slow recovery, whatever you want to talk it, say with commercial heat pumps, then we're looking for a storage volume of what the peak demand is. So 100% of the peak demand. So there's already a big difference in your storages. How we size things. Apartments, we allow 25 litres for a studio apartment. So student accommodation, 1 bedroom, sitters, that sort of thing, 25 litres. 40 litres for a 1 bedroom, 70 for a 2 with 1 bathroom, 75, 90, 110 and 150 litres for Adam's penthouse. So that's what we allow for things. And as I say, this is information that's been gathered for many years, not just here in Australia, but across America as well, where we've done a lot of data logging and we know these figures are pretty correct. Commercial offices, 1 person per 10 square metres, net allowable area, half a litre per person for amenity use. End of trip facilities, 25 litres per shower per use with 4 uses over the 1 hour period. Now, that can vary a little bit for between 4, 5, even sometimes 6. Just depends again on the facility and what the end of trip facility is servicing, what that could be. We typically allow about 4 hours between the morning peak and the lunch peak. So by the time everybody's ridden their bikes in, got their lycra off, had a shower, gone up to do some real work, then it's usually a good 4 hours or so before they head back out at lunchtime for a run around the lake and looking for more showers. Hotels, 25 litres for a 3-star, 250 litres for a glass washer. In a restaurant, we allow 5.5 litres per 3-course meal, which allows for preparation, serving and cleaning. So if you've got a 100-seat restaurant, it's 5.5 times 100 is how much water we would allow for that restaurant. Okay. Obviously, cafes and things like that are going to be a little bit different. Gymnasiums, basically the same as an end of trip facility. Aged care facilities, 25 litres per person for showering, 10 litres per person for room cleaning, 2.5 litres per bedpan. We allow for this, as we said before, over a 2-hour peak. So this is based on 1 person per room. Kitchen, same thing. If they're preparing meals for these people, it's 5.5 litres per meal, but over a 2-hour period again. So it brings it back a bit. Commercial laundries, we're looking at 1.2 kilograms per room, 10 litres kilogram per hour over a 5-hour period. This is the example. I'm going to shoot through this. How do I go back? This is the example we're going to look at today to do the sizing. So we have an apartment building, which is 30 1-bedroom apartments, 40 litres each, 40 2-bedroom apartments, and 20 3-bedroom apartments. Estimated peak hour load for that apartment block would be 6,000 litres at 65 degrees over the hour. So that's what we're aiming to get to. We just have to work out how we're going to get there. How the plant is selected. Make these animations. How do I go back? Right. Assume the data. How the plant selection. Allow for the peak to be covered by storage. So you're allowing for 6,000 litres of storage. That's the heat pump, and I've stuffed it up already. I thought you said you were going to take all these animations out for me. This is for the gas. So we're going to start with the tank pack. So it's still the same thing. We're looking at 6,000 litres. We know that we're going to store about 10% of that 6,000 litres. So we know we only need 1 tank, 1 410 litre tank. That's the largest storage tank that we make in vitreous enamel. So that brings our figure back to 5,590 litres. We have to determine the megajoule per hour required to heat 5,590 litres through a 50-degree delta T. So the difference between the incoming water temperature and the temperature that you want running around the building for 5,590 litres, how many megajoules it's going to take to do that? Adam's going to help me. The formula is energy equals the 5,590 litres multiplied by 0.0042, which is the specific heat capacity of water. Okay, that number doesn't change. You'll see it come up again in these calculations. Every consultant here would know that number. Half the plumbers have all been taught that number, but have probably all forgotten it. That is the number that it takes 1 kilowatt, 0.0042 of a kilowatt of electricity to heat 1 litre by 1 degrees at sea level. Is that it? You're nodding your head, you've got no idea. So it's that divided by the efficiency of the unit. The efficiency of a gas unit, we've been fairly kind there. We put it in at 0.84% efficient. Okay, so 84% efficient for the gas unit. So that's what the 0.84 is. So we now know that we need 1,393 megajoules per hour to do that project. Each continuous flow hot water is 210 megajoules. So we know that 210 into 1,393 is going to be 6.6. Unfortunately, we don't make 0.6 of a heater. So you've got to go to the next one. So you're looking at 7 continuous flow gas heaters and 1 410 litre tank. That's what that installation is going to be. For the heat pump example, I'll get this right in a minute, George. There we go back. I'll have to keep going. How the heat pump. So we're allowing for the same thing. We're looking for 6,000 litres of water, but we know we have to store 100% of that load. So we now have to store 6,000 litres. We know that same formula. The energy equals the load times C times the delta T, C being 0.0042, divided by the efficiency, or in this case, the COP of the unit. The COP on these units, again, we've been very, very generous, and we put it in at 3.6. So we know that 6,000 litres multiplied by 0.0042 times the delta T divided by 3.6 is going to be 348 kilowatts of power required to do that unit. Each of our 30 kilowatt heaters, heat pumps, YF heat pumps, on average put out between 10 and 29 kilowatts. So allowing for a 4 to 6 hours between the peak periods, 348 kilowatts divided by 29 kilowatts times 6 hours equals 2 30 kilowatt heat pumps. So a 95303,000 is a 30 kilowatt heat pump. So we know that we need 2 heat pumps, 2 30 kilowatt heat pumps, and 6,000 litres of storage to do that project. That's the difference between the two. So that's what we've got to price up. Assuming the daily load is 1.5 times the peak hour demand, we're looking at 9,000 litres over a day. Okay. We need to consider the energy required to raise 9,000 litres by 50 degrees C. Standing heat loss, fuel costs, plant equipment and installation costs, not normally taken into the example. So the tank pack, each energy required to raise 9,000 litres by 50 degrees for a tank pack is 2,242.5 megajoules. Okay? Daily standing heat loss is 11.5. That is the heat loss from the 1 410 litre cylinder that you've got sitting there. Okay, so there's going to be some heat loss from that over a day, we admit that. So that's what the standard heat loss is. So 13.7 megajoules. So your total energy consumption for the day using the tank pack is going to be 2,256.6 megajoules. If we assume this presentation was done a couple of years ago, so it's going to be a lot different now, but it's going to be a lot different between gas and electric the same. So we're assuming, these are just numbers to give you an idea, but we're assuming that the cost of a megajoule of gas is 0.04 cents. So $90.26 per day, or $32,945 for the year to produce the hot water using a gas tank pack for that project. If we do the same thing with the commercial heat pump, we still need the 9,000 litres. We're still raising it by 50 degrees. You can see there that we need a megajoules of 471. The standard heat loss in the tank's now 116. So it's 116 on a 2,000 litre tank. Okay, and you've got 3 of them. So 3 times the standing loss on a 2,000 litre tank adds up to 116. So 116 divided by 3, which again is the COP. And again, we've been very generous there. We're going to say you need 38.6 megajoules. The total energy consumption is 509.6 megajoules per day, excluding building pipe work heat loss. So we're not working on the heat loss in the building. That's for the consultants to work out. So assuming the fuel cost, again, assuming a couple of years ago, they were both done at the same time, is 0.35 kilowatts per hour, it's going to be $49.56 per day, or $18,089 per annum, versus $32,945. So your annual saving between putting in a commercial heat pump or putting in a gas unit is going to be about $14,800 per year. That makes sense? Nobody nodded. Good. The budget estimate is 1.7 tank pack with the flues. It's going to be about $37,000 plus. The best estimate on the tank pack is going to cost you about $125,000 plus. This is the initial installation. So you've got a big job talking your customer over parting out with $125,000 against $37,000. But you've got to be able to show him the benefits. So if you do the sums there, we're talking of a payback period of about 4.9 years. So after that time, he's putting money in his pocket. Okay?
Does that allow any redundancy? So say with the tank,
No.
if one of the units goes down, you'd still have to go with the 7. You wouldn't add an additional.
As redundancy,
Yeah.
if you're doing it in a medical situation, so it was a hospital, instead of, if you required it, it's, what is it, N+1?
Yeah.
If you ever see N+1 on a plan, you know that they want double what the spec unit or the requirement is. So if that was a medical, say it was a hospital and it needed 7 burners and 1 tank, they would want to see 14 burners and 2 tanks. So again, depending on what the installation is, how much redundancy you want to build into it. Any questions on 4 or 5 times? Yeah. One of the big things, like footprint and weight. Now you all of a sudden you're going from putting, a metal frame with a couple of continuous flows on it and 1 tank up on the roof to putting 3 2,000 litre tanks. So it's a huge difference. Obviously, you need to employ, structural or civil engineers or structural engineers to work out how that is going to be done and whether it's capable and that sort of thing. More so when people come to you and say, I've got this gas unit sitting on top of me pub, I want to swap it over to heat pump. And you say, well, you can't put it up there, you're going to have to put it on the ground. The roof won't take it. So there's all those things to look into, and the actual footprint itself. Remembering that we now have a range of tanks from 325 litre in both stainless and vitreous enamel, 410 litre in vitreous enamel. We've just started manufacturing our own 1,000 litre stainless unit at the old Aquamax factory in Melbourne, in Moorabbin, where all of our stainless products are manufactured. And we go right up to a 5,000 litre tank. So 1,000, 2,000, 3,000, 4,000, 5,000. So a lot of tanks, a lot of sizes, and they're a multi-use tank that can be used for other things as well. But what that means is that if you're going to put, say, 7 410 tanks in, you might be able to drop 2,000s in or something like that. So we can reduce that footprint in a lot of areas to try and help out. The other thing we can do is all of our heat pumps come in either vertical or horizontal discharge. So the horizontal discharge units are also stackable. So you can stack them too high. So again, for that footprint, if you're trying to bring it down as much as you can, you could put stackable heat pumps and use larger size tanks that are not going to take up as much room as multiple tanks. So there's ways that we can sort of work around things. Yeah.
Do we need?
The only extra drainage from a heat pump is condensate. So they do dump a lot of condensate because of just the nature of the way those systems work. They have a condensate drain on it. We just drop it out the back of the unit. So again, depending on where it's going, if it's in a plant room or something like that, you're probably going to want to feed that to a floor waste or a ton dish if it's sitting up high enough or something like that. Outside, it might not be causing any problems. You might just let it run or put a small piece of hose on it. Again, just depends on each installation. But condensate is not a concern, but it is something you really need to look at. Yeah.
It's not acidic. It's just...
No, it's water. You could drink it. Absolutely, yeah. And that's what most do. Yeah. But it is. It's not acidic water like the condensate you would get out of a gas continuous flow unit. It's different to that. So it's not going to do the damage or brown the concrete as much and that sort of thing. Any more questions on sizing? Yes. Yeah. Technically, you could put a horizontal on the bottom and a vertical discharge at the top.
Yeah.
But if you were going to stack them, you'd probably use 2 horizontals.
And does that then increase your required area because your discharge?
It changes the clearances around the unit where you needed a certain amount of room for the air intake on one side. That probably doesn't change. But where you were going to blow the air out the top, it was just going into the air. That's fine. But now if you're pumping it out the side, you have to be aware of what it's hitting or what it's blowing into. And you will have a fight with the mech guys because they'll say, hang on a minute, you're blowing cold air into my equipment and those sort of things. So all of those sort of things have to be taken into account when you're doing it.
Can they be ducted?
They can. We have them as ducted units. Now, they need to be ordered as a ducted unit. They are different. The fans that we use in the ducted units are slightly differently.
That's all.
They've changed that. Don't worry about it. They're all ducted.
It's only just been introduced, mate. Sorry.
He didn't tell me. He didn't tell me. No, Adam, they are all the same and they can all be ducted. So you have both horizontal and vertical ducted. We would suggest that you initiate an air handling person to design your ductwork if it's going to be a big ductwork. And you can run it quite some distance, but you would need an air handling expert to design that for you. If you're just going to put it in a plant room and shoot it out through the wall this far, you can figure that out yourself. Okay? There are obvious requirements when the units are installed internally for both air to get into that room and air to get out of that room. If you have them in a confined space, they will eventually turn that room into an esky. So, and then it's only going to be sucking cold air into the unit, and obviously the unit is not going to perform. So you do need, and there are information in our installation instructions, or talk to us. There are sizes and things like that that you do need to allow for for ventilation in and out. Okay. Installation. Some of the, and I'm going to touch on clearances here, Adam. Some of the things that I guess we see out there that are common installation mistakes. It's amazing, like we were saying before, how many of these things that we're selling is just unbelievable. And we can't be over the top of every installation. So there's installations out there just getting purchased and put in, and we don't know about them. We know it's been sold. We don't know who to, because it went to a restore or a trade link store or something like that. Who they sold it to, they often don't let us know. So we don't know where it's being installed and what it's doing. And it would be scary to think what some of those installations would be like, because there are some things out there that we've almost, Scotty hit on it today. We're also almost going back to the days of Raypack, when you had to manifold units together and manifold tanks together. You know, the days of buying a skid that you just whack on the wall and plug into the wall, those days are gone. So we have to get our heads around the installation side of things again. And you can see from that installation, that's the basic way an installation would work. You can see your cold water coming in the bottom, going up. You always go in and pick up your tanks first. Now that water's going into those tanks from left to right. So it has to do a reverse return to go back to the heat pumps. The water coming back from the heat pumps must go back into those cylinders left to right. And if it doesn't, you need to do a reverse return to make it do it. You also have to do the balancing on the actual heat pumps themselves. So you have to pick up the flow and the return out of the heat pump and make sure they're balanced. And then you have to make sure the heat pumps and the tanks are all balanced together. So it's not a real easy to look at it, it's a simple job. If you trace the pipe work through, like most plumbing things, it becomes obvious of how it needs to go. As long as you know a few little things about balancing, what we call equiflow, and manifolding of units and how it should be done. There's only one way. There's no black or white. It's only one way it should be done. Clearances, you'll see from that, that's actually a 16 and a 35 kilowatt unit. You can see from there the sort of clearances that you need around those units. And they are different to what we used to ask for around gas units. On the evaporator coil side, so the side that looks like a radiator, you need at least 500 mil on a 16 or a 15. And on a 35 or a 30 kilowatt unit, you need at least a metre. Okay, so that already cuts down your sizes. On the back side of it, you need nil on a vertical discharge unit. On a horizontal discharge unit, totally different. But on a vertical discharge, you need nil. You would probably run it 200-300 mil off the wall, because you're probably going to have pipe work running up and down that wall. So in reality, you would keep it off the wall. Technically, you could put it up against the wall. Then where are you going to run your pipes? Horizontal discharge, you need 1200 mil at the back of the unit and 2 metres at the back of the unit for the 35 kilowatt. On the display side of the unit, so the way these units are built, one end has a panel that comes off. That's the display side. That's where the electrician needs to get in, the refrigeration mechanic needs to get in, the BMS guy needs to get in. That's where all their business is done, in that end. So need a good 850 unless he's a fat little refrigeration mechanic and you need a bit more. But we always look for a minimum of 850 so somebody can get in there and do the work. Down the other end is where you're doing your work, but you're only hooking a couple of pipes and a pump up. So remember that you've got a pump on every heat pump. So every heat pump needs a primary pump. So you have to hook that primary pump up at the other end usually. That's the most convenient place. It can go elsewhere because it's a pump, but it needs to be hooked up at the other end of the unit. So we ask for 600 or 500 at the other end of the unit. Top discharge units, or off the top of the vertical discharge units, we're looking for 1200 or 2 metres. Now you look at that 2 metres, you say, well, hang on a minute, the unit's over a metre high and you want another 2 metres on top of that. You can see all sorts of issues there where you could be hitting ductwork, ceiling, other equipment, all sorts of things. So those sort of things, that's what I say, you need to look at every installation differently and say, can I fit that unit in there? And a lot of the times, the guys are designing these systems may not as yet have the mechanical drawing, so won't know where the ductwork is or where the electrician decides to put his ladder tray. And that can make a big difference. If you have air coming out of the unit and it hits something, it's going to bounce back down. So if it bounces back down and gets drawn back in through the evaporator coil, it loses the effectiveness of that heat pump. So you need to take that into account, okay? And it's not hard. You just got to look at it and say, what's the best way to do this? Or, sorry, Sparky, you can't run across the top there. That's my area. Okay. Pipe sizing, depending on how many heat pumps, you're going to have a header and a footer, and you're going to have branches. Again, going back to the days of manifolding, we all know that all the branches have to be the same length. They all have to also be the same diameter. They all have to also have the same fittings on it. And that's why you'll see when we ever draw a plan, when we come to the end of the run, we'll go past that last, what would have been an elbow, put in a T and then blank it off separately. That makes all the inlets and outlets from that product T's, not T's and elbows. Okay, so just little things to look for, depending on how many heat pumps you've got. If you've got just one 35 kilowatt heat pump, you're going to have a 50 mil branch and you're going to have 50 mil headers and footers. So all of the primary pipe work between the heat pump and the tanks is going to be 50 mil. If you've got two of them, it's going to be 80 mil. If you've got three, it's going to be 100 mil pipe. Okay, you can still run your 50 mil branches off that 100 mil pipe, but you're going to be running 100 mil pipe between your heat pumps and your storage tanks, both flow and return. Okay. Obviously, there are different size pumps depending on the size of the heat pumps. Now, that's all heat pump sizing, header and footer sizing, all that thing is designed by our R&D people to be correct. Now, that's allowing for 20 metres run. Okay, so if it's over that 20 metres run, you need to talk to us. We'll run it through our calculator and say, no, that pump will still do it, or no, you might need to upgrade that pump to something different. It's only a matter of talking to us. We'll help you out.
Also, if you've got more than 4 units manifolded together, talk to us about the header size and the branch sizes. It doesn't really change often after we do our calculations, but just if you've got 6 units manifolded together, come to us just to check that manifold.
I had one the other day. It was 8 30 kilowatt heat pumps, 3 4,000 litre tanks, and he ran the whole thing in 100. It was fine. Oh, sorry, in 100. Yeah, where if you do the actual calculation, it was asking for 150. If you stuck to the formula, but we were able to check it out with the distances and that sort of thing. We got it back to 100. One of the things that has become very prominent in Victoria, and I assume it will down here too, is people using stainless instead of copper. One, because at the moment it's probably cheaper. Copper's fluctuating all over the place. Stainless is fairly stagnant. So stainless at the moment is a little bit cheaper than copper. And in Victoria, at least, the amount of theft that's happening with copper. They don't pinch stainless. So we're seeing a lot of whole jobs done in stainless now. We're talking manifolding. We talked about it before, but it honestly irritates us a lot when we go to jobs and we see not only has the plumber put it in wrong, but the consultant has also drawn it wrong. And I think sometimes people just copy and paste because we see the same one turn up on drawing after drawing. So, but it's something that I guess more so as the installers need to be aware of how it needs to be piped. That is a fairly quick example. Forget all the numbers. That's a fairly quick example of how not to do it. If you piped it like that, you would get all the water going through the first tank. Easiest path of resistance is to come straight out of that tank. So why would it go down to this tank or even look at this tank? That's it in a nutshell. So you have to overcome that. And the way to overcome that, if your cold water's coming in on this side and your hot water's going out on that side, if your hot water was going out here and you came straight out, it wouldn't be a problem. But if your hot water has to come back to here, then you need to do that. And as plumbers, everybody knows it. Doesn't mean everybody does it. Okay, so that's what we talk about when we talk about equiflow or balancing or manifolding the units. Now, some of these installations can get very intricate in what they do. We offer as a service any project that our product is going to be used on, that is, there's an order in the system, then we will do site-specific drawings for that project. So we'll go out on site, we'll meet with the contractor, we'll measure it up, we'll know where the things are that can and can't get hit, where things can and can't go. In the early days, we'll talk with them and the developer about where the plinths are going to be and all that sort of thing. We'll have all this drawn up way before they start, so they know where they're building their plinths, where things are going to sit, and then we'll do them a pretty colour picture on exactly how the pipework needs to go. Okay, so you can see from that it can get a little bit intricate in just where things are going. The other part, I guess, of electrification, which is something that we are now in, is a product called Ream Eclipse. Ream Eclipse is a three-phase continuous flow electric hot water system. We have it in two sizes. We have an 18 kilowatt and we had a 27 kilowatt. Both of those units are available in either a preset 50 or 60 degree model. The 50 degree model is trade adjustable to 55 to allow for some of those dead legs that might be a little bit longer than expected, trying to keep those temperatures up, similar to the regulation on continuous flow gas units, where a 50 degree continuous flow gas unit can be tricked up to 55. But it's trade adjustable. The customer can't do it, okay, unless it's a tradie. Just to run through it, the design of our unit, we're talking about the time that it saves for that cold water to get to be usable hot water, and the difference with some other manufacturers. So it's not going to work for me. I hate that. We're the pink line. So you can see by that, we achieve a usable temperature about 11 seconds quicker than some of our competitors. Okay. Sizing, this is all on our website. If someone wants to look at it to work out what size unit you're going to use. Generally speaking, I would be looking at probably only the 27 kilowatt units here in Tassie because of your colder ambient temperatures. These things are not going to run a house unless it's a small house. You'll get a shower and a basin out of it quite adequately, but they're not going to do 2 showers. So we have a lot of builders ring us up, say, oh no, we've got to go electrification. I'm going to put one of those instantaneous units in to do me 3-bedroom house. And they just, obviously they don't know what they're talking about. They're comparing an instantaneous electric with an instantaneous gas, and they're 2 totally different things. But that's just something that you need to be aware of. We now have the units available. Sizing, we spoke about. Any questions on anything? Scotty, I'd love to answer them. Nothing. I believe I did a real good job or a shocking job, Ryan. And now it's trivia time.
Okay. One up for Matt, and then we'll have a quick break, and then we'll kick on the last one.
Okay, guys, so round two, question one, we're talking about how long Australians spend in a shower. So there's the Water Conservancy research released in October last year shows that Australian average duration of a shower has shifted over the past decade. It was 6.5 minutes, but new research shows it to be either A, 4 to 5 minutes, B, 5 to 6 minutes, or C, 7 to 8 minutes. So it's shifted over the last decade, and it's gone from 6.5 minutes to research now showing that it's 4 to 5 minutes, 5 to 6 minutes, or 7 to 8 minutes. Okay, question two. This is Mario. And remember, don't yell it out. But this guy has a brother. What's that brother's name? And Pete from his last presentation asked, well, he let us know, but tell me, where are the Rheem heat pumps manufactured? Where are they manufactured? Yeah. Town, not country. That's right. Looking quite specific here. Okay, that's round two. We've only got one round left, so hopefully you're doing okay. Perfect. All right. We'll just have a quick break and then keep going. Yeah. Keep going. Okay. All right. Okay. Next up, we've got Paul Fisher from SFA Group. Yeah. You can use that, all the buttons.
Yep. Thanks, guys. Once again, thanks, Rheem. Obviously, it's always great to be here. But this is my second time I've actually come here. It's fantastic. So thanks a lot. Pretty much SFA, well, we've changed a few times now. SFA Group, but we're now actually SFA Pumps. We are formerly known Saniflow. So, okay, so we've got all this into, click all this through. Yeah, that's all right. So, yeah, so pretty much we're the inventor of the macerator pump itself. Our products are made in France. So back from 1958, we now have, we pretty much deliver our pumps over 30 countries around the world. Obviously, we've been in Australia since 1988, and pretty much over 1 million units are produced every year. A lot of questions I do get asked, are they watermarked? Are they approved? Yes, they are. So they wouldn't be going in, and yes, they have to be installed by a licensed plumber. We're the only company which has got both domestic and commercial options, so throughout the complete range. I've got one over there today, which if you later on, if you get time, I've got one of the macerators up there. So that's domestic or light commercial. So our ranges are obviously as well. We've got a macerator pump, grey water pump, and also lifting stations. So we got to the next one, which is this again. Sorry, I'll just click all through so we can see everything here. Also with that branding, so it was pretty much started around the 2021. So how we are now is we are
as I said, SFA pumps, and our products fall in different category names. So we have Saniflow, which is our original macerators, grey water pumps, lifting stations, and then now we do have our in-ground lifting stations, which we call them as the Sanifos range. We completed Certificate 3 plumbing courses over the last couple of years, obviously, especially with COVID and so on. So we do train students at local TAFEs or RTOs. We also offer technical presentations to, obviously, hydraulic consultants, architects, and we also have our plumbers CPD, which I've handed a couple of brochures out, but there's a brochure on the table there, which is a few QR codes, especially the plumbers portal. On there, there's actually, you just scan that, it goes to our plumbers portal on a website. You can go in there and complete an online CPD, which is current. So it'll save you $70 instead of going it through Points Build. So it's free to use. So. She's probably on that. So yeah, just touching base back on that Saniflow side of things, everything has changed to SFA pumps, but you can still use the old URLs. We do have another pump, which is coming, which is totally changing our standard of macerators and moving grey water and wastewater. We have a new unit called a Rain to Home, which is a submersible pump, which has got a changeover device, which once the water runs out dry from the tank, it'll automatically change over. That's probably going to be released around April 2026. So next month, fingers crossed. All right, so pretty much the nitty gritty. So why and when would you use now we're saying SFA pump or a Saniflow pump? So I'm tipping a lot of plumbers would have installed these before. It's when obviously you can't get to the main drain. So, or you can't get obviously your 1 in 60. Also, the installation of new fixtures may be in the middle of an existing building away from your current services. Especially we see this with consultants is when design constraints make it too difficult. So, you know, especially when you look at architects as well, when they want to put a toilet over there, the main drain's over there and you're on a concrete slab, or the bathroom. So first of all, we'll cover off a macerator. This is one thing which people do get confused, and what I hear all the time is I need a macerator, and it'll actually be down to they want a grey water pump. So macerators, when we use these, is when we're connecting to a toilet. If we have grey water fixtures going to it, we're just a grey water pump. So these units have got blades or grinding plates. So when you actually look at the actual macerator pump itself, you've got that point for the toilet. That is where the blade sits. So once that toilet waste goes in there, it's getting chopped up just like a blender. Those other two connection points, they don't even touch those blades. Unless we start getting into commercial, yeah, it'll hit a grinding plate. But really, that is where the waste goes in. That's where it's going to chop up. Sorry about your dinner and everything like that, but that's where it's going to chop up your pea pool paper. So just like a blender, it converts everything to a slurry. Ideally, you need about 4.5 litres of water to mix with your waste. So what we sort of suggest is with a toilet suite, disable the half flush. What we find, and it's probably, especially, you're probably finding in commercial situations as well, or light commercial, is if people sit down to pee, they'll put toilet paper all around the toilet, they'll sit down, do their business, push all that toilet paper and then push half flush. The chances of that blocking is pretty likely. So that's why we always say disable the half flush. With those macerators, best practice, toilet straight into the pan collar and away you go. If you do have to extend it, majority of the units is maximum of a 300mm pipe piece from the pan to the macerator. So normally what would happen is they would, you box it out in that situation, so it'd be nice and hidden. So obviously looks. always make sure you've got an access panel. Then we go on to grey water pumps. Once again, as I mentioned too, grey water pumps, there's no blades in these. So it'll pick up, designed for sinks, basin showers, dishwashers, washing machines. Once again, all pipe sizes are quite small. So I should have mentioned on your macerators, majority of pipe size discharge in 20 mil pressure pipe. Whatever's specified on the spec sheet, that's what you use. Normally tip for your vertical lift. Once you get on your horizontal, if you're going further than 5 metres, you'd increase the neck size, which is only 25 mil. So it's very, very small pipe, and that's pressure pipe. When we go into the grey water, pipe sizes do increase. We do go to 25 mil, same thing. When we get up to a horizontal, we'll go into 32 mil. Two different types of units there. That one there's domestic / light commercial. So it could be office, home, office kitchenette. We see a lot of these in Victoria. We've got 7-Elevens, so service stations where they've got coffee machines, but they're automatic type, just so where it's just discharging. They're sort of, watery sort of waste. Then we've also got our heavier duty units. So this would be our more commercial, so higher temperatures. That unit there is rated to about 75 degrees for short periods of 5 minutes. This one here, you're probably around 90. So this unit here would say be used for, could be, you've got cafes, bars, hair salons due to, say, chemicals and so on. Anywhere where there's high temperatures or slight chemicals. We tend to use those on a few schools in their science labs. So when they do pour stuff down there, they don't have the activation's a bit different. These use a rubber membrane boot. If you do have a look over on that unit later on, you'll see that. These use a pressure switch. There's a pressure tube which runs down and activates that way. Then we go across to our freestanding lifting stations. So when we look at these, there is a couple of units. There's ones which are a grey water lifting station. Once again, you saw that picture of that singular unit. That one there, we call it a Sanicom. There's a twin motor unit of that. So it could be a bigger restaurant, more flow rate, could be a laundromat where you've got multiple washing machines and so on, bigger discharges. These two units here, they're actually, they'll actually do wastewater and grey water. So these units, instead of a blade like those ones over there, they've actually got this unit on the left-hand side has got twin pumps. They've got grinding plates at the bottom. So there's a few different types. There's a singular unit which we can use for, say, a granny flat. Or it could be a caravan park, something like that, tiny home. Then we've also got twin pumps, a lot larger. So that singular pump, you'd say one toilet, whole bathroom, whole kitchen. When we start going to the bigger units, we're looking at, it could be 10 to 12 toilets plus wash-up areas. We use a lot in mining or construction sites. But we still always say with majority of these pumps, the 3 Ps, pee, poo, paper only. If there was a situation where, say, a nightclub or you did have a big construction site where there was possibilities people throwing, plastics and so on down there, we do have a unit which has got vortex impellers and pretty much it's got a 50-odd mil opening. Anything that sort of goes through there, it'll pass through. But that comes with discharge pipes a lot larger. These units here, you're looking at a 40 or 50 mil discharge. That bigger unit, you're looking at 100 or 80 to 100, depending on the pipe run. But saying that, there's sites where you'd need it. So coming back to, like I was saying, the newer units. So they're in-ground lifting stations. So this would be perfect, ideally, when you need holding storage. So somewhere where you haven't got actually you're connected to the mains sewer. So pretty much these come as a full assembly. So they'll have, obviously your tank, your components of your pump, high level alarm. When you do get to your bigger units, they'll have twin pumps, especially when you get to your thousands. So a lot of these pumps here will pump up, say, 11 metres or 100 odd metres across. There are units out there which can go up, say, 200, up 20 metres or 200 metres across. When we look at running on flat ground and so on, we do use friction loss calculators, make sure we can actually do that. So once again, with sizes, different states, different councils, for the holding capabilities, they may request different sizes on there. So for instance, I know Victoria, they sort of roughly base it off size-wise 150 litres for the first person, and then say 120 for the next person after that, just being that they allow the extra 30 litres for, say, run off hot water service, washing machine, dishwasher. So, but once again, each state can be different. And I have found that a lot with a lot of other bits and pieces too. So this is the new pump that I was talking about before. Submersible pump, float to cut it off in and out. It's got your rain to home. So switch on there. So once that tank water runs out, automatically change over. And so all of a sudden, once the tank fills back up, it'll switch back to tank water. This is new for us. This is totally something different. Hopefully it's all up and running next month. It has taken a while, but that's life. A couple of newish products. So the first one on the right-hand side there is our Sani interlock alarm. So that unit there will pretty much be compatible with all our pumps. So what that actually does is, in the event of a blockage, it's got a few things. In event of a blockage, it'll shut the pump down. It'll send obviously it's going to shut the pump down, but the pump's going to already shut down. It'll send off alarm. It's got BMS. It also comes with a solenoid valve, which with options of 2, which that'll get cut into the mains water supply. It'll actually shut that water off, so no one can go and fill up the sink and continue overflowing. It's also got a 240 volt plug underneath the bottom where you may put a dishwasher or a washing machine, and it'll cut that switch down too. So one thing, if the power does go out with this, being that the solenoid valve, we call it a latching coil, it'll send a pulse down there and it'll shut the water supply off. So obviously there's no chance of people running that tap if the power's out. Another one here is our Sani hair. So when we deal with hair salons, there is an issue. Normally it's not the hair by itself. What it is, it's the actual hair and the products that they use, which causes an issue. So when it obviously goes through, that hair and the product bind together and it actually blocks the impellers. So this unit here just sits prior to the pump itself. It can pick up 3 hand basins or hair basins. And what happens is that, depending on how busy the hair salon is, they'll undo the lid, take the hair out, off they go. So it just protects the pump. It saves pulling the motor of the pump out and cleaning that instead of just easily unscrewing the lid on there.
How big is that unit? Oh, sorry.
Actual size-wise, probably about 300 by, 300 high. So it's quite small. It'll do 3 hand basins and it just sits next door to the unit. I have, once again, talking about install, I have seen a plumber run it below the floor and then try and go back into the pump, and it doesn't work. Yeah. There's no trap on it, so it pretty much just goes through. There's you could say a sieve inside. Water drops down. Obviously, hair stays in the sieve, and then it just keeps going on the other side. So there's no trap on it. So
Can you maybe submit it as water for,
yeah, yeah.
then you could use it without a pump.
Oh, the hair trap itself. Well, saying that, I'll double check with our main tech manager. I'm surprised it wouldn't be. Everything else about stuff's watermarked, so I don't know why that wouldn't be, but yeah. Couple of considerations especially when we go about pumps. So when we're thinking, or when we got to size the pump itself. So the first of all is our pump curves. So first of all, how high do we need to pump the actual waste? So how high do we need to lift it? And then how far do we have to push it horizontal to the final connection point? Then we also need to work out how many litres are expected to be discharged. So how many fixtures are we picking up? Is it a sink? It was a dishwasher, or is it a toilet? So then using pump curves, we can then determine will the pump cope or not. So this is pretty much just going back on pipe sizing again. So the discharge line, as I said before, majority of the small units are 20 mil pressure pipe or 25. On our manufacturer's recommendation, it'll have that written on there. Always go by that. We have guys which all of a sudden they go, no, we're going to put in 40 or 50 mil pressure pipe on the vertical and stuff like that. And it's like, no. Sometimes, and you see it when you do go through your friction loss charts and you put them all through. Sometimes you can overspec it and you don't get enough velocity to actually clean the pipe work, to scour the actual pipe itself. So a lot of time people go bigger is better, but not always. Change of direction. We always use 245-degree bends to create a 90. So it's a nice sweet bend. We get less friction loss through that, and you get less blockages as well. So there it is. So normally with that friction loss for 245s, to create that 90, you lose about 0.5 of a metre as a guide. Okay, so when we do get up to the top of our vertical run, what we want to do so once we get to the top, we turn in the corner. On that horizontal run, we want to try to achieve 1 in 100. It's not much. Sometimes it can be very tight. It just really does help with any friction loss, and and even when you change direction on that, while we've got that 1 in 100 on that horizontal, it doesn't really make too much difference. So we don't really have to allow for that half a metre. So pretty much off there, we're saying you'd come up, once you go across, if you're within 5 metres, you can continue, say, 20 mil, your small line, but as soon as you go further than 5 metres, we need to increase that pipe size. Once we get up there, if there's situations that we've got to run flat or we're running uphill, for every 10 metres of that flat pipe is 1 metre of friction loss. So we've got to start adding all this together. So all of a sudden, we've got to start adding the vertical lift, the horizontal run, how many change of direction. So it can all add up quite quickly, and you can also get over over the spec of the pump itself. So if we just have a look at this next one here, and I'll just flick back in a sec. This is a typical schematic where we can't achieve that 1 in 100 fall. So say we've gone into the roof space, all of a sudden we've got a beam coming through, and we've got a dog leg around that. So we've got to go, okay, what's our friction loss through here? So first of all, we've got our 2.5 metre rise. We've got our change of direction. See how we haven't got our 1 in 100 fall because we've got to go back down. So we obviously add up that 2.5 metres, add up all the change of direction and that length of pipe. So our vertical rise is 2.5, total is 6 change of direction, and we've got a total horizontal run with no grade, obviously 2.5 metres plus the 3 metres ahead for the elbows and 1 metre of head for the 10 metres of flat pipe. So we've got 6.5 metres. You'll see on most of our products will have 2 types of graphs. So all of a sudden, when we go into that scenario, we'll come across here and look at this pump curve here. So we'll go, all right, 6.5 metres. What do we got? We got about 40 litres a minute. Are we picking up a sink? Okay, that's fine. 6.5 metres, 40 litres a minute, no worries. You could probably pick up 2 sinks, probably pick up 3 hand basins. That would be fine. We can cover that off. We probably wouldn't use that other calculator or that other sheet across on the other side in that scenario. That one there is when we sort of go, we've got 1 in 100 fall. We can go, we're going up 2.5 metres. We need to run 50 metres across. It's nice and easy, nice and simple. A couple of do's and don'ts. So do use 45-degree bends for change of direction. And I know I'm going to get other ones down here, so people can ask questions. On our units, they all come with check valves. So all our macerators, our grey water units, they come with an elbow. And in that elbow, there's a non-return valve. Don't throw that elbow away, because we see that a lot and people jam 32 mil pressure into the top of it and they wonder why the pump keeps turning on and off, because they've got rid of the check valve. So it's fine. All you need to allow for on that is a ball valve. Do not use air admittant valves. Another one, no AAVs. So again, all these pumps need to breathe in and out, especially when we go to our bigger lifting stations. As soon as you throw or install a AAV on there, there's a lot of there's sensors and stuff like that in the controller, and obviously there's also alarms. It will go haywire, and it's pretty much a lot of the time I get phone calls of guys going, you know, I've got this Sanicom, it just goes, I'll just see a red flashing light all the time, and straight away I just go, first of all, have you got an AAV on it? And it's like, oh yeah. I said, while we're on the phone, just cut it off, and he goes, oh yeah, it's fine now. It's because they need to breathe, because otherwise all you're doing is you're just building up a chamber of, you know, of waste, and that's it. And the air can't go anywhere. Oh, there we go. So, okay, this is probably one which it is different from state to state, local authorities. So if you cannot, ideally all macerators, so anything which is going to take the toilet, they have to be vented to atmosphere. Grey water pumps, so so once again, if you can't vent, you literally cannot get a vent out with a grey water pump, so the smaller units. Once again, it's state to state, but as the Australian standards say, you can rely on the built-in carbon filter as long as the pump's in the same room as the apparatus that you're picking up, so the sink, say you're picking up, and there has to be a service schedule in place to replace that carbon filter. So you can do it. On our bigger units, and this is the one which, again, it really is purely state to state, the vent size on those are a lot larger because they're pulling a lot more water and volume coming into them. So you literally need to vent at least 50 mil off them. Some states allow you to use a plastic eco vent, which is a two-way carbon vent, or a Studi Maxi filter. So as long as you've got some type of service schedule in place to change that carbon over. Some states will not use that at all. You're not allowed to use it at all. So, but it can be. I know Victoria, yes. Here, I believe so. As long as you've got that service schedule in place. Do follow AS 35.2 for drain lines to pumps or for elevated drainage. So once again, you'll install that to your plumbing regulations and connections to the inlets as well. So for those, if majority of those, a lot of people go, it's 40 mil, I can't get my shower into it. You can actually use a 50 mil slab repair, which will just push straight into that, and you're not reducing pipe size. And the same with our bigger units. If you want to go if you need to get 65 mil into it, you can use a 65 mil slab repair into it, and you're not reducing pipe size. There's a couple of things there. So there's your connection to your common drain. So normally it should be 2.5 meters between connections. And yeah, normally rolling on the top. Okay, so on our slides here, so for the designers, we've got designers hub. So pretty much on that same catalogue, there's 3 QR codes on there, one for the designers, one for the plumbers and one for stores. If you scan that, you go straight into our designers hub where you can sign up for CPDs, browse the CPDs courses. You can get all our products. Yeah, pretty much everything you need. So once again, it'll actually go through it. So this way here is if you're actually going through our website, so you can see Designer Hub and go to the products, and it'll open up to each of the products. So in this one, it's showing you kitchen and laundry pumps. So it's not going to have anything to do with a macerator in there because there's no toilet going to be connected to it. So, and then on each of the pages there, once you go into that product, this has changed. So this website used to be a little bit different. Now it's opened up to more specific sections. So in here, we've opened up to a Sunny Speed, which is a grey water pump. Now we actually want to get the information from that. So spec sheets, datas and so on. So up on the top right-hand corner, it's got the get docs. So then you can get product sheet, manuals, BIM objects as well. I don't have it on here, but like I said before, on that flyer, there is also that plumber's portal. If you did go to our website, you would have seen up there. I don't know if it's loaded or not. Doesn't. So yeah, you've got professionals, design hub, and then underneath is that plumber portal. It's the same sort of area, but it's designed for plumbers. So there's videos on there, there's installation videos, which cover off all your regarding your air AAVs, how to vent, how to run your pipeline, and there's once again there's that CPD. And with that CPD, you do get a certificate, which I'll send out to you as well, so you can file that away. Well, our promise from SFA, inventive solutions, quality. Obviously, everything's made in France. If there was an issue, we don't want the plumber to return it back to the store, especially like a macerator full of waste. We have our own technicians who will come out on site and they'll actually go through it. So, which is pretty quick. So the turnaround is normally, by the time paperwork's filled out, it can be 24, 48 hours. Stress that it's really urgent, be quicker. So we do have an exceptional service, and obviously being that the French, always continuous improvement. And that's me. Any questions? Or is everyone ready to drink some more beer? And any questions? No? Okay. Trivia time. Thank you very much.
Thanks, Paul. Reem just wanted to remind everyone the apprenticeship grants are back open. There's 25 up for grabs, $3,000 each. Go to the Reem website to look into it. Thank you. All right, Matty's up for finishing off the trivia. I hope everyone's getting good. We're almost at the end, right?
We are. This is it, guys. This is the very last time to hit the lead if you're not already there. Okay, so this is round 3, question 1. Only 3 questions to go. The moon is smaller than the Earth. In comparison, the moon is 15%, 20%, or 25% the size of Earth. So the moon is smaller. Is it 15, 20%, or 25% the size of Earth? Okay, so question 2. Question 2. What nationality was the famous explorer and navigator Abel Tasman? And following on from Paul's Saniflow discussion we've just come off, where are the Saniflow pumps manufactured? Hopefully you two are doing all right on this table here. Okay. Well, look, give you another 30 seconds or so to wrap that one up, but I'm going to move straight into the answers now. This is a self-regulated test, so we're looking for some honesty at this stage. So round one was the what's the largest copper structure? Did anyone have anything in particular, or it is the Statue of Liberty? It's the third largest. So if you had Statue of Liberty, give yourself a point. The two tallest structures are two residential towers in Manhattan, standing at 48 and 41 stories. They are